So we just wrote a lot of contracts to try and get more experience with that and just watch some of the different features unfold as we use the language. So I'll just start out with one here that we wrote, and they got more elaborate as we went on. But one idea is we just wanted to write a contract which is going to sum two integers, and we came up with something that looked like this, where we've got a channel, we've got two channels coming in, and oh, of course. One bit of terminology that came up, which was interesting, is the difference between a type and a sort. And sorts are what describe the values that can fit within a variable. And typically, a sort is just going to be the Java primitive types and then wrapped up in various sorts of channels and all the different sorts of nested ways that those can be built. And then a type refers more to what the output from a contract. And that's where the behavioral typing can come in. So, did I not say?
A point of clarity, it's not necessarily the output of a contract, it's the behavior. Contracts don't necessarily have outputs.
Right, yeah, the behavior, thank you.
No, it's a term of art.
Okay.
Milner gave that in the polyadic pi calculus.
And actually, what we were calling the type here, what Greg said described the behavior. Oops.
And you may have noticed that I used the idea of sorts in Levier theories, and that's also standard from algebraic signatures and means something different from what it means here. So.
The sorted situation.
So we know we want to fill this in, with the semantics of what it means to add, what we grab from each of these channels.
You need a closed paren here for that.
Oh, thanks.
And then a colon.
Colon, okay. This is the behavioral type here.
Yeah.
And the way to read that is that A and B are consumed and that there's output on the sum channel.
X plus Y.
Yes, yes.
And just, I don't mean to be pedantic, but it would be star X plus star Y, which is, a little bit of a wart in the language.
So, this is an example of the first contract that we kind of worked through.
Sorry, about the dereferencing. Like, if I know that, I guess it seems weird to me that I have to always dereference it. That seems like it's going to just increase the number of extra characters I have to type, and there's going to be, it's like putting a semicolon at the end of every line. This doesn't. If it doesn't need to happen, why does it?
We've gone around that. For Mercury, it's just going to be a wart. And so here's the trick I used to do with my editors. I knew that they really, really wanted to prove their value, so they needed to rip up prose somewhere. So I would always put warts in my prose for them to rip up on purpose. So that's one of these.
I'm just curious, it's a wart, but you could get rid of it, but you'd have to introduce some symbol, sort of say the name itself. If you did that, kind of. I'm just.
Yeah.
Sure I understand.
Yeah. So there is redundancy, but if you remove that redundancy, then there's all kinds of overloading and ambiguity that suddenly you have to disambiguate in some other clever way. And so we need the other clever way, which we don't necessarily have yet.
I don't understand the spatial type that's after the signature, the colon.
It's a behavioral type.
That's a behavioral type. Can you explain that?
Yeah, sure. It says, it's possible to read from A and B and then output on some. Great question. That's a really good question. Okay, good. So this says I can kind of restrict what's going on at A, right? And this says I can restrict what's going on at B. But there's no way in something that's talking about A to talk about things that might happen to be across A and B. And notice that this one constrains stuff across A and B. So I'm kind of thinking once again. Yeah, sure. So a sort restricts what's going on at A, right? Or what's going on at B. Now, what if I wanted to restrict information about the relationships across A and B? I can't put it here because that's just about A. I can't put it here because that's just about B. Where am I going to put it? That's what the behavioral type stuff does.
Just one bug that we actually wrote by accident that what Greg was talking about would have caught is if you would have had this here, which is semantically meaningful, but it catches the behavioral type here because B is not consumed in here.
No. So to make it compile, do this. Right? And then make this one C, right? And now that violates the behavioral type.
Yeah, just in our session, we had said the behavioral type was read as there is input consumed from A, and there is input consumed from B, and there is output placed in sum, which is different from can input A, can input.
Oh, sorry. Yeah. So the definitely is versus may is so you'd make it square for necessarily, right? And rectangle for may. I mean, sorry, angle brackets for may. And then there's a not possibly not is the same as.
So yeah, the particular syntax of these types and sortings are yet to be finalized. Yeah. But I was just wondering about the meaning of for x from A semicolon y from A. That seems to, I mean, if it were y from B, we would need x and y to be available simultaneously on A and B. If you put A in the second one, what does it mean for x and y to both be simultaneously available on A?
That was the deadlock. That's why I said it might not compile, right?
Compile.
That one doesn't compile?
Yeah.
Okay.
Yeah, because A is shadowed.
No.
What? Maybe I misheard your example.
For x from A, y from A,
Yeah, that's
P.
Yeah, that's what I meant. That doesn't compile. That's a deadlock.
Why would it be a deadlock?
Because I have to receive twice exactly at the same time.
But you could easily have A bang Q pipe A bang or Q1 A bang Q2, and they're both available exactly at the same time. Right. I'm just saying, why couldn't X and Y be bound to Q1 and Q2, or vice versa? Either way suffices.
I see your argument. Yeah, it is. I can buy that one.
Okay, so I just wanted to know what the semantics were, and that seems like a reasonable one.
In Rosette, that should totally be doable. Yeah.
So my question is based on this, what we just talked, what Mike was implying. You can take out the B and C from the up. If you remove it, then how will you define the behavioral type if you are getting X and Y from A itself?
If it were that way and you didn't have the B and C arguments,
Right. So
you just had an A and you took 2 from A.
Right. So I would just add A colon and then some colon, right? Then how will you define the behavior type? A only, or some, or
No, you have to do it. It has to be A comma A.
A comma A.
And you're reading it twice.
Okay. Thanks.
So reading from A twice, is that
So that because it's in the same step.
right? Yeah. No,
Sorry. Go ahead.
I get that when you're trying to read from it twice and it's in like 2 places, that's allowed, but that seems very like anti-idiomatic. Like it's, I don't know. Seems like something that should be discouraged from being done.
No, I just want to disambiguate doing it in sequence versus. Oh.
Okay. Cool.
I could insist, to prevent some kind of race. That first I read and then I read, as opposed to because in this one I'm going to get them in some specified order, and this one it's not intentional.
But in the thing that Mike wrote down, where it was reading from the same channel at the same time, is that like, while we all, I guess, agreed is allowed, should it be allowed?
Yeah, it means that you have to have two at the same time there in order to proceed. The bottom type he did there in green, you can read one and then wait until the next one shows up. And that will capture the first one and not let it go. Whereas with the double, you can have one sitting there for as long as you want, but until the second one shows up, it won't fire off. And so that one that's sitting there may be consumed by something else. So those are very different requirements on the channel.
In other words, so what Mike is saying is, so first to the what I'm hearing is the deep point of your question with respect to should. There's a nice by simulation argument that Mike just gave. And that's what helps us adjudicate these kinds of semantic discussions. So in particular, once you've committed here, that one is gone for, whereas here, it's only ever a partial commitment until you have both of them. Yeah.
Yeah, I think one can create some race condition or wave condition.
So we did some more involved examples, but I don't quite remember them. I don't know if anybody wants to try and pitch another one, but
The one that Michael had proposed was a kind of aggregator, and that raised some interesting questions, but maybe we could take it offline. It doesn't necessarily have to be. But I would love, we can go over it if you want to. Do you remember the aggregator one? Okay.
So the basic point that I was trying to get at with this example was passing processes, right? Because in functional programming languages, it's easy to write generic code that you pass in a function to and it does a thing. And aggregation is an obvious example. So the idea was that we have a contract called egg, and say it takes in an argument L, which is some kind of list over integers. And then I don't know if this is exactly how that type is supposed to look, but I hear that list is going to be a primitive, so or an allowed type that we can put in the language. And then I have some process, which I want to consume my list and process it in a particular way to get at a result. And we want to aggregate over these things. And so the question was, what should the type of this thing look like in order to specify that this is going to consume a list?
Yeah, but remember, the P is not actually going to be a process. It's going to be a name.
It's going to be a name of process, right? Sorry. Yeah, so we ended up writing something that looks like this.
Why don't you, instead of calling it L, call it something else? So we
Sure.
don't get
Any ambiguity.
Yeah.
We should call it X. For X in. It has to.
Well, how about call it C for collection? And we use X for the source, and you have to pass in the source.
Oh yes, that's right. That's what it was.
That was the subtlety here.
Right.
And there's some,
Yeah. We out that. Right. So the idea was that I need to be looking for input that's waiting for a collection. And so the question was, how should I know what channel my collection is going to be on? And then the answer was, you include it as an argument here. So you also have X. Yeah, exactly. Which is the channel that you expect to get your list on. And then this is all fine, and we can write. Basically, what we want to do is invoke P in parallel with Yeah. Yeah.
So there's some subtlety there, right? Because we've now got X bound up in a free name bound up in that type there. So the compiler would have to match this against that and be happy with that.
What does the at on the P mean? That it's in the namespace of that process?
So P is not a process, it's a name.
Right, but L is apparently also a name.
L is a value, right?
Which is a process. Except we can't.
So the way the current spec works, contracts are only parametric in channels and values, right? So values are the only things that you can pass directly. If you want to pass an arbitrary process, you have to pass it as a name.
Okay, I would have expected to see L colon at list int and then X bang star L.
Yeah, understood.
But
So does this iterate or just? Well, so we didn't get in.
Iteration is inside P.
Yeah, we didn't get into this detail, but this true here should be substituted out with something that says I consume my elements of my list pairwise and iterate through. Yeah, something along those lines. But we didn't.
To clarify, the one that we're showing there, that's just sending the actual list, and then the continuation is where the original is.
Yes, that's right. But the reason we didn't end up getting into that detail was because apparently folds are going to be in the language anyways. So this is like fold.
We've got fold left and fold right as. That's more or less what we talked about.
So if my 4 years of managing programming teams using almost exclusively Go has taught me anything at all, it's that for most programmers, reasoning about concurrency and channels is excruciatingly difficult, right? And so the rule of thumb, even in that language that advertises itself as good for concurrency, is to avoid them whenever possible, right? Right? I'm going somewhere with this.
I know.
You want another example?
Yeah.
Okay. Because most people, this is great and it's interesting, but this is not where you start, right? This is where nobody starts these things. This is where you end. You start because you have some familiarity with a language that, like Python, where you do, okay, find the sum of two things, find the difference of two things, and then return the sum times the difference and the sum over the difference, right? Return. It's Python. Got to tell it. Right? No channels required at all in the interface here. You want an int and another int, you want to do some things, and then you want to return a pair of ints, right? That should be pretty straightforward. I didn't know how to do it, but we did come up with something, right?
Yeah.
So this is contract F. It takes A, which is an int, B, which is an int. I don't have a return statement, so I need to put that somewhere. Unfortunately, require a channel. We just CH here is what we're doing.
Yeah.
That takes, we're going to say it's an int. That's integer. It's an int. I don't know how to write it. We're going to do that. I'm not going to do behavioral typing on this.
Okay.
I don't have anywhere. I don't have this kind of syntax for storing an intermediate result. So I can reuse A plus B everywhere I need it, A minus B everywhere I need it. Years of training has told me that's a really bad idea. So I need to discover how to do that. And the easy way was, well, add the things and stick them in a channel, right? You subtract the things and stick them in a channel. and then you return.
Well, you're gonna have to do it for.
Yeah, I got to pick up those things, right? I want to, yeah. Conceptually, I want to return the pair. I don't know how to write it. S and D, more or less. Yeah. Right?
Wasn't it S times D and S divided by D?
Yes, it is eventually that. I'm kind of working my way there. I don't have yet names for S and D, so we're going to call them X times Y. And is it infix, really, in this language? Okay. And X divided by Y. Something like that. And my X's and Y's come from here. And there it looks fairly straightforward, right? I think this is the kind of thing people are going to need to see first, right?
So to clarify, I think to make this compile, though, you would need to have new S colon channel int in new D. Yeah, you'd have to declare them first.
Yeah. Which we didn't. Can I do this? So I don't have to write it? Yeah. Okay.
Would it make sense to like sugar this into like a let for things that where like the channel, like if we're not returning the channel, like it just makes sense to like sugar this down to a variable?
Well, I think that's the decision you make when you decide this isn't good enough, right? And for me, this is on the boundary, right? Because we can kind of make it look like that. I don't know if this is more complicated, if they still look the same-ish.
Yeah, well, part of this is going to be answered by the answer to algebraic data types and the total functional sublanguage.
Not for those people I'm talking about, right?
Well, no, because that will become part of the syntax of the language, and it'll look a lot more like this. So one thing that I had proposed earlier that sort of matches with the data type would be for S gets A plus B, D gets A minus B, and then you do this stuff.
Yeah, that's a let.
Yeah, it really is a let.
We like lets.
But see, what we've got here is a total functional sublanguage that has a single output, and living in that spot, then we can make some reasoning about it.
Yeah, and that's lovely. And this is the intent. I think, again, I hate to say it, but part of this is just marketing. Part of this is just marketing. We put the thing out with warts, and then we show improvement. I don't want to, sort of, release early, release often, right? So we get the thing out, get people playing with it, and then now here's a nicer way to do what you've been painfully doing for the last,
So about the warts. Okay, so if I'm not mistaken, on the left, we'd have to dereference X and Y, right? We'd have to star them.
Yes.
Right?
Yes.
Okay. Yeah, exactly. So I was just thinking, just brainstorming here, but a possibility is to make the quoting explicit. So if we decided that we did want to quote something and then send it and then have to evaluate on the other side, then we put an @ in front of it when we send it. Yeah. And if we don't, then it's just sent and we don't have to dereference. Yeah. Exactly, yeah. Which is an optimization, but just a thought.
Yeah, understood. Yeah, I've thought about that one.
Did I hear the same thing or different? These are patterns, true?
What?
Right here, Y is a pattern and X is a pattern?
They can be, yeah.
So can you write @ there? Does that help?
Yes, you can write the @ there and then destructure, so that would be a potential way to do it. That's a very nice one. That's a good observation. Yeah, I see what you're saying. So yeah.
2 or whatever. Instead of the star here.
Yeah. That's not a bad way to do it.
But that isn't dereference. Well, it's still coding.
I don't know.
This is a really good idea because to is a process. And when you pull from, if we're thinking of this as being a process sent over an anonymous channel, then what comes out is the name of to. And then you destructure it to get the process to.
So channels and processes can go on the right-hand side of that arrow?
No, that's...
This is currently not part of the language, but
Okay.
this is potential suggestion. Yeah. So I think in what I had originally done, I even used an equals sign here.
Right.
So that it really was just a let.
That's a very nice. That's better.
Yeah.
Although I would use the cold equals.
So, like, I'm okay with warts, not necessarily on purpose, but as like we can get it done faster this way, and we have a process for how to dewart it later. Yeah. That's perfectly fine.
Cool. Anything else you want to touch on for the
Liquid nitrogen. So weren't there 3 breakout sessions?
That was the third.
Oh, right. Yes, Dan and